Alright, so we're going to learn about piecewise functions today. Piecewise gets its name because they're going to be split into pieces, and then we're going to be dealing with functions, and so every x has its own y value. So here is what a piecewise function looks like. So you're going to have multiple functions. So you could have multiple lines, you could have multiple curves that you'll learn about next semester. But they're going to be in function notation, which means you're going to have f of x. And then we've got this little bracket to represent all the functions we're going to use. And then, like step functions, you're going to have these intervals where it's going to be open or closed on, okay? So remember, if it's equal to, it's going to be closed circle. If it's not equal to, it's going to be an open circle. And we're only going to cover a certain part of the domain, okay? So first off, we're going to learn how to read and evaluate. So when you evaluate, remember, you're going to substitute in, you're going to plug in. And so with piecewise, you just have to figure out which one to plug it into based off of this domain. So if I want to find the value of f of 1, I need to figure out where 1 would go in this domain. So 1 would not be less than -1, but 1 would fall in between -1 and 3. So I'm going to be plugging in this 1 into that middle equation. So I'm going to go ahead and rewrite that. So when I substitute 1 in, remember, you're going to use parentheses, and so I'm going to plug in 1 for x squared plus 3. Now you could type this in the calculator, or you could solve it by hand. I'm going to solve it by hand real quick. So 1 squared would mean 1 times 1, which would be a 1. Drop down the 2 and drop down the plus 3. 2 times 1 is 2, and then plus 3 would be 5. Okay? So f of 1 would equal a 5 for the first one. On the second one, f of 6, 6 would be greater than a 3, so I'm going to plug it into this last equation. So I would have -1/3. I'm going to plug in my 6, subtract 2. Okay. Now I'm going to show you guys how to do this in the calculator so I can remember how to do a fraction. Alright, so remember in your calculator to bring up a fraction, you're going to press the alpha, y equals, and then enter button. Of course, mine's not going to work because mine's an older version, but again, alpha, y equals, and enter for a fraction, or you could just do a division sign. So I'm going to do -1/3, and I'm going to plug in 6, and then I'm going to subtract 2. So you should get -4 for the second answer. Now, the last two have stars on them, and that's because they're kind of tricky. So 3, for example, I see 2 3s up here. And so what that means is you have to figure out which one it would go into. And since it wants 3, that means it should be equal to 3, which means I should plug it into this middle equation. Okay? So sometimes you have to figure out which one to use. So I would say 2, plug in 3, squared plus 3. Okay? I'm going to show you how to type that in, just in case you forgot. But of course you could do it in your head. So you would have 2 parentheses 3, and then if you want to use the squared term, it's right here, or you could raise it to the squared power, to second power, with that button, and then add a 3, and you should get 21. Okay? Alright, last one that I will do would be f of -1, and I am confused because I don't know which one to plug it into, but I know it should be equal to -1, so I'm going to use the equal to, so I'm going to use the top equation. So I would say 2 times -1, subtract 1. Now I can do this in my head. 2 times -1 is -2, subtract 1 would be -3. Okay, so that is how you evaluate piecewise functions. The trickiest part is figuring out which one to use, but just use your knowledge of inequalities and greater than or less than and equal to figure that out. So why don't you guys try this whole problem right here. If you're confused on this exponent, it would be a cubed, and so like in the calculator, that's like multiplying it by itself 3 times, or you could raise it to the third if you want to do it in the calculator, okay? So try those 4 on your own, and then press pause, and we'll go over them. Should have gotten 2, -6, -13, and 5. If you were confused on the first one, when it said g of -4, you'd plug it into this first one, and if you don't have an x or anything to substitute in, that just says, hey, the value is 2 for everything that's less than -2. So you would just tack down that number 2. On these middle two, pretty straightforward. You plug in the -1 into this middle one because it falls in between that range. Here you would plug it in to the middle one again because it is equal to -2. And then on the last one, g of 5, it was this last one, and then it said x, and so you would just input 5 right there, and you would just get a 5 back out. So anything you input, you would get as an output. Okay. So let me know if you have any questions on evaluating with an equation, because we're going to move to evaluating on a graph. All right, so when a piecewise functions are graph, they look like multiple pieces, hence the name piecewise. We know that the piecewise graph shown below is a function because, so remember our knowledge from functions in Module 2. Remember the vertical line test we did, you didn't want to hit 2 points vertically because that means you would have 2 x values and you don't want your x's to repeat. So the following is a function because it passes the vertical line test. Okay, so this is an example of what a piecewise graph would look like. You've got some line, closed circle, open circle above it, similar to step functions, except they don't look like steps. So they're going to look like a bunch of functions on the same graph. So we're going to learn how to evaluate from a graph. It's very similar to what Module 2 was. If it's in parentheses, those are your x values, and so you're looking for your y value. So if I'm looking for x as a 3, I'm going to go on the x-axis 1, 2, 3, and I would have to go up right here to hit a point on the graph, and then I'm going to go over to that y-axis, and that y value would be a 3. So f of 3 would equal 3. On the second one, f of -3, I would go to the x-axis of a -3, 1, 2, 3. I would go up, and I'm going to go to the closed circle because that means there's a point there. So if I went up 2, that'd be a positive 2 on the y-axis. F of 0 means I'm going to stay at x of 0, which is right here, and I would have to go up 1, so a positive 1, and hit that line. F of 2, let's go over to 1, 2. Now again, this is tricky. Do I go up or do I go down? Well, there's not a point here, but you're drawn to it, so you're actually going to go to the point that's closed in circle. So you're going to go down 1, so -1. And then lastly, f of -127. Well, you guessed it, it's not on the graph. So where would it be? -127 will be somewhere all the way over here. And so what we notice is this line is going to go on forever and ever and ever and ever and ever. And so if that line goes on forever, that y value is still going to be at a positive 2. Okay, so anything after what, -3 is going to be a positive 2 value for a y value. All right, so let's take a look at this bottom one. The piecewise function above is shown on the right. Try finding the function values you found above. Did you get the same answer? So let's pick this one. F of -3. Let's look at all these functions down here. So -3 would fall into, would it be here, here? Let's see, it's going to be equal to it. And so that means it'd be a 2, which works out. If I wanted to try 0, because that one wasn't any fun, 0 would fall in between a -3 and a positive 2. So I would plug in 0 into this equation down here, and I could get -0 plus 1, which would just be a 1. So it worked out. Okay? So if they give you a graph, you can determine it from the graph, or if they give you functions, you can plug them in like we did above and do it from there. Okay? All right. I want you guys to try evaluating on your own from a graph. So try these 5 and this crazy graph. And if you can figure out this bottom, what are some things you notice that will help us graph them ourselves? Go ahead and take a look at this down here and see if you can figure that out. So try those 2 and then press pause. Alright, so you should have got -3, 1, -2, 1.5, and -1. If you have any questions, let me know, but I am going to go over this fraction one really quick because fractions tend to trip us up. 5 over 2, if you just typed it in the calculator, 5 divided by 2 would be 2.5. So if you like to work with decimals, change them to decimals. But you go over 1, 2.5, and then you had to go up 1.5. Do you know it's a half? No, but you can take a guess. So it'd be 1.5, or you could do a mixed fraction as 3 over 2. Okay? So if you have any questions on this one, let me know. Let me talk about this one real quick too. H of 1. So again, if you go over to 1, you do not go to those open circles because there's not a point there, that's why you have to go down 2 for that one. Okay? Maybe you figured this out, but I mean, I can't either if I didn't know what it was. So I'm actually teach you how to graph them and then talk about how that makes sense. All right, just kidding, you try. So Jack claims that the graph to the right is a function, but Sally says that it's not a function. Who's correct, Jack or Sally? Okay, so give me a nice sentence explaining who's right and who's wrong, and give me some reasoning. Press pause, go. Hopefully you agreed with Sally because Sally is correct. A good justification could be Sally is correct because the graph fails the vertical line test at x equals 2. You could say Jack's wrong because my x values repeat at a 2. If you have any questions, if you're right or wrong, please raise your hand and I can come around and help you out. Otherwise, we're going to move on to graphing because y'all don't know how to do this yet. Alright, so we're ready to start graphing piecewise functions. One of the easiest ways is to draw a table, or you could draw invisible walls and make tables. So, invisible wall, what they mean is if I look at this domain, I know -1 is important. Something's going to happen at -1. So what you could draw is like an imaginary little dotted invisible wall. Something's going to happen on the left side, something's going to happen on the right side. Okay? But I think tables are the easiest way. So what we're going to do is we're going to pick some values that are less than -1 and put them in a table. Okay? So we're going to do that in our first one. So let me write that equation down. 2x plus 6. And I want to pick x is less than or equal to -1. So let's start with -5, -4, -3, -2, -1. Okay. That way I can figure out what's happening on the left side. So this is just like functions for Module 2. To find f of x or your y values, you're going to substitute them back into your equation. Okay. So I'm going to plug in -5 into my equation and see what my output is. So 2 times -5 plus 6. Okay. 2 times -5 is -10. -10 plus 6 is a -4. Okay. So then I'm going to plug in -4. Two times -4 is -8. -8 plus 6 is -2. Okay, so if you're not getting the hang of that, please let me know. But that's what you should get if you are substituting in your values. Okay, so now I can graph that. So I'm going to graph the point 5, -4. So to graph a point, I'm going to go on the y-axis to a -5 and then down 4. And then I'm going to go for -2. -4, -2, sorry. So notice my slope is up 2 over 1, which makes sense because in Module 3, that's my slope of 2 over 1. So then I've got -3, 0, -2, +2, and then -1, +4. Okay, so that is my first part of my function. Okay, so it makes sense because my slope was 2 over 1, that line's going up, etc. Now the second part, you are going to pick values x greater than -1. Okay, so I'm not going to pick -1 on this one. Just kidding, I am. Alright, so I'm going to pick -1. Greater than would be 0, 1, 2, 3, you could do 4, 5, 6, etc. So I'm going to plug in those values into my second function. So I've got -x plus 1. Okay? So if I plug in -1, I'd have -1 plus 1. I know 2 negatives together is a positive, so that's the same as 1 plus 1, which would be a 2. If I plug in 0, 0 plus 1 is a 1. If I plug in a 1, I'd have -1 plus 1, which is a 0. If If I plug in 2, I'd have negative 2 plus 1, which is negative 1. And then I would have negative 2. Okay? So notice this table makes sense because my initial value was at a 1, and then my slope was going down by 1 each time. But now I'm going to plot them. So I'm going to start at negative 1, 2. Negative 1, 2. Now, is it an open circle or a closed circle? Okay, you've got to look back up here, and since it was not equal to it, it's going to be an open circle right here. Okay, so it's going to pick up there, and then I'm going to go 0, 1, 1, 0, 2, negative 1, etc. So my slope is going to go down 1 over 1, down 1 over 1. Then I'm going to connect those points, and I've got my other function. Okay? So that's how you graph a piecewise linear function, and we're only going to be dealing with linear right now. We'll be dealing with curves and all that next semester, or next couple months. So, important points. Something is going to happen at a certain number, where it's going to jump up, which is hence piecewise. One will be closed, one will be open, because it is a function. You can use your knowledge of slope to make sure your line is correct. You can create a table, etc. Alright. Now, I want you guys to try this one on your own. Don't be confused by that 3, it's a little bit tricky. But try it on your own, and then we'll go over the answers. So press pause and try it. This is what your graph should have looked like for the second one. This 3 was a little bit tricky, but what it means is it's a horizontal line because you don't have an x, you don't have a slope. So I tried plugging in numbers less than 0. So I did negative 5, negative 4, negative 3, negative 2, negative 1, 0. And then, hey, if they just give you a number, it's straight 3s down the whole side. So all you had to do was draw a horizontal line through a 3. Now, I did a closed circle, but it was open to begin with because of this right here. But when you plug in values that are greater than 0 here, so again, you start at 0 and plug in greater values, you notice that you had the same initial value. So I did have some overlap on this problem. So that open circle became a closed circle after I plotted this function over here. And so once I plotted the points, I just graphed the whole numbers. You don't have to worry about the decimals on that one. But notice my slope was 1/2, and I went up 1 over 2, up 1 over 2. Okay? So that's how you graph piecewise functions. They are a little tricky. They take some practice. So let me know if you have any questions. Otherwise, you can start to master that and practice it. So thanks for watching.